Okay, everybody, so today we're going to be looking at how we can draw vectors to determine the overall change in position for an object. So I thought we'd quickly review what a vector is. So if you remember, a vector is some kind of measured quantity that includes a direction associated with it. And what we can do is we can draw these vectors using arrows. So we were doing that the other day. And we saw that the magnitude or the size, so magnitude just means size, of a vector is represented by the length of the arrow. So the longer the arrow, the bigger the vector quantity is. And to figure out how big it should be, you use an appropriate scale. And then the direction that the arrow is pointing is the direction the object is moving, its actual displacement. And when we measure vectors that are angled, we measure from the closest compass point. So let's take a look at a couple of examples. So in the first situation here, I've got a vector. This line segment, according to my scale, represents 100 meters, and it's going towards the north. So this is a vector going 100 meters north. Now this one over here, I've got this vector. The length is representing 220 meters according to my scale. And my angle here, I'm measuring the angle from the north. So this vector is going northeast. So I'm measuring from the north. I'm going to figure out how far to the east I go. So when you're drawing this vector, it'd be north 30 degrees over to the east. This vector over here, I'm going southwest. So I measure the vector from the south. That's the first direction here. And it's going to be measured over towards the west. So 45 degrees over to the west. And then I've got my vector to the appropriate length. Now, what we can do with this is we can draw several vectors and figure out the overall displacement for the trip. So here's an example. This is from our note from today, where I've got a vehicle, some kind of object, that has different components. So it's going from here to here. So we've got one displacement, then we stop, then we ended up going up here. So we've got another displacement. We'll label this D2. And then we even have a third displacement. So what happened is I started off over here. This is my initial position. And I ended up over here. And even though we did quite a few components in terms of the motion, oftentimes I just want to know the overall displacement or change in position for a trip. And that's called my resultant displacement. Think of it as the shortcut vector. So the resultant displacement represents the overall displacement of an object from the initial position to final position. Again, it's kind of like the shortcut vector. So if you can take a shortcut, the shortest possible route, this would be it. And the thing to remember as well, you always draw this vector to dr from the beginning, the initial, to the final position over here. So let's take a look at an example. So what I can do is I can draw a diagram for these vectors. So these two vectors here. So I've got this one vector, 35 kilometers north. So according to my scale, this would be it over here. And my scale is 1 centimeter is 10 kilometers. So my vector here is 3.5 centimeters long. It's going to the north. And then this one here, the second part of the motion was 20 kilometers east. So according to my scale, the line is 2 centimeters going this way towards the east. Then what I did is I drew a line from the initial position down here to the final position over here, connected the 2 points. And then I put an arrow here. So I'm going to think of it as a shortcut vector. So I label it delta dr, resultant. I measured this line. It was 4 centimeters, which means it was 40 kilometers of using my scale. Then I have to measure the angle. Now I know my vector is northeast, so I'm going to have a north component and an east component for this angle. I decide to measure from the north. So I'll be measuring north, and I looked at the angle. This angle was 30 degrees. So I measured north 30 degrees over to the east. And that's what I write down in my square brackets. So that's how you draw a scale diagram to figure out the resultant displacement of a particular vector.